Good morning, students. I'm Dr. Sushil Charpe, Assistant Professor at Department of Physics. So now we completed our unit number one. After the unit number one, we have to move on our second unit, that is unit number two, that is the laws of thermodynamics. And these laws of thermodynamics are very easy or very basic knowledge which related with the branch of the physics. Okay, so in 11th standard, 12th standard, or in 10th standard, you already study this laws of thermodynamics, and there are the three laws: first, second, third, and the one additional that is zeroth law. So these are laws of thermodynamics includes a fourth law. So we have to see the what is meant by thermodynamics. Next, before we start this thermodynamics, so first question is arises that what is meant by thermodynamics? The thermodynamics is the branch of physics that deals with the relationship between the heat, work, temperature, and energy. In broad terms, thermodynamics deals with the transfer of energy from one place to the another and the another form into the other form. The behavior of heat, work, and temperature and energy are governed by the four laws of thermodynamics. So we include this part in the thermodynamics. I think in first part we see the kinetic theory of gases. Okay, वहाँ पे हमने गैसेस का थ्योरी भी देख लिया, उसका न्यूमेरिक उसका वर्क टेस्ट भी दे दिया। अब हमें इस पार्ट पे मूव होना है, ठीक है। सो बिफोर गोइंग टू दैट, फर्स्ट व्हाट इज मीन बाय एनर्जी आपको पता होना चाहिए। सो व्हाट इज मीन बाय टेम्परेचर, ओके, और व्हाट इज मीन बाय थर्मोडायनेमिक्स, ये तीन चीजें आपको पता चाहिए। तो आप व्हाट इज मीन बाय टेम्परेचर कोई बता सकता है? ओके, तो नाही देखो, जसं आता एखादा तवा असेल, तव्याला जर तुम्ही गरम पाणी असेल त्यात हात टाकला, काय होते? गरम लागते. दॅट मीन्स यू सेन्सेस समथिंग. ओके, दॅट इज नथिंग बट द हीट. यू सेंस द हीट. ओके, अब टेम्परेचर क्या है? इट मेजरमेंट मीन्स यू पुट द थर्मामीटर देयर and you get the accurate temperature of that water or whatever it, the hot body, that is nothing but the temperature. Okay, तो ये टेम्परेचर और हीट में आपको समझ में आना चाहिए, ठीक है। तो इस पूरे यूनिट में हमें क्या चेकआउट करना है कि दैट इज द बिहेवियर ऑफ हीट, वर्क, टेम्परेचर एंड एनर्जी विच इज कोरिलेटेड और गवर्न बाय द फोर लॉज ऑफ थर्मोडायनेमिक्स। सो वन बाय वन हम उसको चेक करेंगे। सो फर्स्ट लॉज इज that is zeroth law of thermodynamics. So according to the zeroth law of thermodynamics, if two systems A and B are the thermal equilibrium with the third system C, then must be thermal equilibrium with each other. Okay, in simple language इसका मतलब क्या है? For example, एक चेम्बर घेतला असेल तुम्ही, if you are taking a chamber और उसमें एक A ऑब्जेक्ट रखा है और B बाद में C, ठीक है। अब और A, B और C के बीच में फॉर एग्जाम्पल A का टेम्परेचर 40 डिग्री है और C का भी टेम्परेचर 40 डिग्री है। सो व्हाट मीन्स दैट B का टेम्परेचर ऑटोमेटिक क्या हो जाएगा? 40 डिग्री सेल्सियस। और दूसरी तरह का, इफ A और B are in thermal equilibrium means they have do not means त्यांचं टेम्परेचर जे आहे काय सारखं आहे, याचा अर्थ तिसरा सुद्धा काय असेल? must be equilibrium. So this is a zeroth law of thermodynamics. So what is meant by zeroth law of thermodynamics? According to zeroth law of thermodynamics, if two systems A and B are the thermal equilibrium with the third system C, they must have the thermal equilibrium with each other. In the above statement of the fourth law, इसको हम फोकस करते हैं। Just a minute. In the above statement, the statement called as the zeroth law of thermodynamics and the form of the basic concept of a temperature. म्हणजे तुम्हाला म्हटलं होतं what is temperature, हा टेम्परेचर कॉन्सेप्ट काय आहे, हा कुठून आलेला आहे? आपला zeroth law of thermodynamics पासून. If these three systems can be said to be the property of temperature that assure that the beginning of the thermal equilibrium with each other, this property is known as the temperature. We may have therefore the define as the temperature of the system is the property of determines whether is not system thermal equilibrium within the other neighboring system. It is clear that if two systems are not thermal equilibrium will be different temperature. म्हणजे याच्यावरून तुम्हाला डिफरंट टेम्परेचर आहे कसं काय सांगू शकता? तर कशा प्रकारे सांगू शकता? जसं तुम्ही सांगितलं की बाबा दोन टेम्परेचर आहेत, दोन टेम्परेचर म्हणजे कसं, समजा एखादा 40 डिग्री एका 35 आहे, हे कसं डिफाईन केलं? अकॉर्डिंग टू द zeroth law of thermodynamics. ठीक है, now we are moving to our next topic, that is uh, हे त्याची फिगर आहे, विथ फिगर तुम्ही कोलॅबरेट केली. सो वी आर मूविंग टू नेक्स्ट बॅक टू अवर टॉपिक. ओके, तो फर्स्ट लॉ क्या, द नेक्स्ट इज दैट the first law of thermodynamics. So what is meant by first law of thermodynamics? The first law of thermodynamics is particular form of the general laws of conservation of energy. Suppose amount of Q is applied to the system, it is normally spent in two ways. The partial is spent on the increasing the internal energy of the system. Second, the remaining part is spent to the expanding the body against the pressure doing the external works. आता एक लक्षात घ्या, आपण 12व्या वर्गात किंवा 10व्या वर्गापर्यंत law of conservation of energy शिकलोय. What is that law of conservation of energy? So that law is that the energy not be created, not be destroyed. It convert into the one form into the other form. So that is nothing but the law of conservation of energy. ठीक है, अब इसको हमने correlate करना है with the first law of thermodynamics. Okay, so what is that thermodynamics? The amount of heat is Q supplied to the system is normally spent two ways. Partially it's spent to increasing the internal energy of the system. म्हणजे समजा तुम्ही एखादा मेटल घेतलं त्याला घालून गरम करत आहे भाऊ, तर गरम करत असताना इट्स स्पेंट टू काय, तर एक पहिलं की त्या जो मेटल असेल त्याची इंटरनल एनर्जी ऑफ द सिस्टम इन्क्रीजेस, म्हणजे त्याच्या इंटरनल एनर्जी ऑफ सिस्टम वर तो गरम म्हणजे इंटरनल एनर्जी सिस्टमची वाढवण्यासाठी काम करतो. रिमेनिंग पार्ट ऑफ द स्पेंट एक्सपांडिंग द बॉडी एक्सटर्नल प्रेशर, म्हणजे दुसरा पार्ट जो असतो एनर्जीचा तो यूज होतो टू स्पेंड एक्सपांडिंग द बॉडी. आता साधी गोष्ट आहे, समजा तुम्ही मेटल असा किंवा प्लास्टिक घ्या, फॉर एक्झाम्पल प्लास्टिक घ्या, आगीच्या खाली ठेवा, काय होईल, तो प्लास्टिक त्याचं इंटरनल एनर्जी वाढेल, म्हणजे काय होईल, त्याचं टेम्परेचर वाढत जाईल. ओके, फॉर एक्झाम्पल सिम्पल लँग्वेज, अँड इट पार्ट एक्सपांडिंग द बॉडी अगेन्स्ट द एक्सटर्नल प्रेशर, आणि काय होतं, ते मेल्ट होणं चालू जातं, काय ते एक्सपान्शन होतं. सो डुईंग द एक्सटर्नल, दॅट इज नथिंग बट अ वर्क. So if delta U is a change in internal energy, since energy can neither be created nor be destroyed, but only convert from one to the other form. So we have this Q. This statement को देखो कैसा है, तो I am focusing that. Okay, so if Q is nothing but the total heat. Okay, so delta U is the change in internal energy, and W is the your work done. So that this equation 1 equals to, that is mathematical statement for the thermodynamics. What is the mathematical statement for the first law of thermodynamics? That is Q is equal to delta U plus W. What is Q? It is amount of total heat spent by the any total amount of heat. Okay, then next delta U is nothing but the change in internal energy. पहले जो internal energy और बाद में के internal energy दोनों का subtraction जो आएगा, that is your nothing but the change in internal energy, और बाद में आएगा work done. Okay, if we are changing, consider small, okay, small quantity में, so if delta Q is equal to delta Q, delta U and delta W are the small changes in heat, internal energy and work respectively. So equation 1 becomes, अब इस equation 1 को हम किस तरह लिख सकते हैं? So it is dq is equal to du plus dw. Okay, so we write it this way. So du is equal to, तो हम इसको लिखना है du is equal to du plus dw. This equation represents the differential form of the first law of thermodynamics, which may therefore is stated in all transformation. The energy due to the supplied heat unit must be balanced by increasing the external energy as well as the internal energy. Okay, so these are the some. This is the first law. अब इस first law के some there are the limitations. What are that limitations? तो हम उसको one by one check out करेंगे. The first law of thermodynamics is basically the principle of conservation of energy. Okay, it plays an important role of thermodynamics as it applied to the known of much work will be obtained by the transferring the certain amount of heat energy in a given thermodynamic process. However, the first law of thermodynamics suffers from the following limitations. That is, first law of thermodynamics does not indicate the direction of heat transfer. Means what it means that if you are taking the some object और दूसरा भी object रखा है, अब इसका 50 डिग्री टेम्परेचर था, इसका 30 डिग्री सेल्सियस, we know that according to zeroth law क्या है कि दोनों का टेम्परेचर इक्विलिब्रियम कंडीशन पे आएगा. अब ये 50 to 40 गया है, टेम्परेचर लॉस डाउन हुआ है, और 30 to 50 गया है, इसका एक्सप्लेनेशन नहीं है अपने पास. So that is the first drawback of thermodynamics. What is the first drawback? The first law of thermodynamics does not indicate the direction of heat energy. Second, the laws of thermodynamics does not tell anything about the condition under which heat can be transferred into the work. Okay. Third, the first law does not indicate as that by the whole of the heat energy cannot be continuously converted into the mechanical energy. Means पूरा heat energy पूरा mechanical energy में convert होता है या नहीं होता है, इसके बारे में हम बता नहीं सकते. आता याच्यासाठी हे थर्ड लॉ जो म्हणजे थर्ड जे लिमिटेशन्स आहे याच्यासाठी तुम्ही कार्नॉट सायकल जे थर्मोडायनामिक्स मधले हे तुम्ही 12वी मध्ये होतं तुम्हाला. सो ये इसको हमें पढ़ना है. ठीक है. सो दिस इज द लिमिटेशंस ऑफ द फर्स्ट लॉ ऑफ थर्मोडायनामिक्स. नाउ नेक्स्ट दैट सेकंड लॉ ऑफ थर्मोडायनामिक्स दैट अब इस फर्स्ट के लिमिटेशन भी पता चल गया हमें. उसके देखो एक वन बाय वन देखते क्या देखा था हमने. जीरो लॉ देखा, उसके बाद फर्स्ट लॉ देख लिया. फर्स्ट लॉ दैट इज कंजर्वेशन का बारे में है, ये भी हमें पता चल गया. अब जाते हैं सेकेंड लॉ के थर्मोडायनामिक्स की तरफ. ठीक है. दिस हैज टू स्टेटमेंट. फर्स्ट केल्विन एंड प्लैंक स्टेटमेंट based upon the performance of heat engine, and second is Clausius statement which based upon the performance of refrigerator. Okay, so Kelvin's and Planck's statement of second law, it is stated that if it is impossible to construct a device which operate in cycle has the sole effect of extracting heat from the reservoir at performing an equivalent amount of work. Thus, single reservoir at a single temperature cannot be continuously transfer heat into the work. Okay, तो ये आपका केल्विन प्लैंक स्टेटमेंट ऑफ सेकंड लॉ. और कॉल्सियस का स्टेटमेंट क्या है? It is impossible to self-acting machine working in a cycle process unaided by any external agency to transfer the heat from the body at lower temperature to body at higher temperature. In other words, it may state it as heat cannot be it cannot be flow itself from the cooler to hotter body. ठीक है. तो ये आपका सेकंड आहे. म्हणजे याचा अर्थ सरळ सरळ यांचं म्हणणं आहे हो इकडे जी एनर्जी तिकडे जाण्यासाठी काही ऑटोमॅटिक जाणार नाही. सो वी रिक्वायर्ड सम मीडियम and that is nothing but the second law. Okay, तो हमें second law तो ये पता चल गया. In this statement, based upon the performance of refrigerator and heat engine working in a backward direction, in refrigerator the working substance takes as a heat from the cold body. Certain amount of work is done on the some outstanding agency rejected a large amount of heat hotter body. Thus, refrigerator transfer heat from the cold body to the hot body with an added of outstanding agency. No refrigerator has a very constructed which cannot be worked without a supply energy from the external agency. So these are the some drawbacks and whatever we have discussed in the first two म्हणजे डिस्कस केल्या जातं दोन लॉज मध्ये सेकंड लॉ मधल्या दोन स्टेटमेंट मध्ये ते यात दिलेलं आहे. नाउ नेक्स्ट that is third law of thermodynamics. According to the third law, at absolute temperature, the entropy tends to the zero and the molecules of the systems or the system are in perfect order, well arranged. This is the third law of thermodynamics. म्हणजे काय? At absolute temperature, the entropy tends to zero and the molecule of the substance or the system are perfectly ordered. आता याचा अर्थ काय म्हणजे काय? ऍब्सोल्यूट टेम्परेचरला एंट्रॉपी म्हणजे काय? एस. एंट्रॉपी कशाने डिनोट करतात? एस ने. तर एंट्रॉपी एस इज झिरो. मॉलिक्युल्स ऑफ द सबस्टन्स इज perfect order or well arranged. This is thermodynamics. The universe, in the universe, the entropy is increasing, and ultimately the universe will be reach a maximum value of entropy when no work done will be possible. With increasing entropy, the disorder of the molecules of the systems is increases. The entropy is also measured the disorder of the system. With decreasing entropy, disorder is decreases. The important concept है. So according to third law ने हमें क्या बताया है? Third law gives us the concept of entropy. तो entropy correlate करता है आपका किससे correlate करता है? Order or disorder. Means if your entropy is maximum, there is a large number of disorders in the molecule substance. साधी गोष्ट आहे. समजा तुम्ही एखादी वस्तू घेतली, ते प्लास्टिक आहे, प्लास्टिकचा डस्टर असेल समजा फॉर एक्झाम्पल, ते गरम केलं, काय होते? ते काय होते? नंतर वितळते, दूर दूर जाते. सो दॅट मीन्स देयर इज अ डिसऑर्डर इन द मॉलिक्युल्स. ओके, सो दिस इज नथिंग बट द थर्ड लॉ ऑफ थर्मोडायनामिक्स. तो क्या है थर्मोडायनामिक्स का? तो ये हो गया आपका थर्मोडाइंस, सो थर्मोडाइंस में सेंटेंस क्या पता चलने रखना है ख्याल में आपको, with decreasing entropy disorder is also decreases, ठीक है, मींस एंट्रोपी इंक्रीजेस, डिसऑर्डर इज आल्सो इंक्रीजेस। तो कितने लॉज है आपके, देखो फर्स्ट लॉ, इससे पहले कौन सा देखा, जीरोथ लॉ, ठीक है, अब मैं धीरे धीरे जा रहा हूँ। देन फर्स्ट लॉ, इसका मैथमेटिकल स्टेटमेंट Q इज इक्वल टू डेल्टा यू प्लस डेल्टा, सॉरी Q इज इक्वल टू डेल्टा यू प्लस W। इसके लिमिटेशंस देखे हमने। बाद में सेकेंड लॉ ऑफ थर्मोडायनामिक्स, उसमें दो स्टेटमेंट है, केल्विन प्लैंक स्टेटमेंट और दूसरा क्वासियर स्टेटमेंट, ओके। एंड थर्ड जो है थर्ड लॉ, that is related with that absolute temperature, the entropy tends to zero and the molecules of the substance is perfect ordered, and this is the third law। इसका मतलब क्या, एंट्रोपी बढ़ेगी तो आपका डिसऑर्डर भी बढ़ेगा। तो ये आपका थर्मोडायनामिक्स। तो इसके बाद हम जाएंगे थर्मोडायनामिक्स का छोटा सा क्लिप है जिससे आपको समझ में आएगा और ब्रीफली समझ में आएगा कि व्हाट इज मीन बाय थर्मोडायनामिक्स। सो बिफोर वी दैट, अगर आपने प्रेजेंट ही लगाई नहीं होगी तो प्रेजेंट ही मार्क कीजिए गूगल फॉर्म पे, और ये जो वीडियो है आगे का, एंजॉय दैट वीडियो। सो इन नेक्स्ट वी आई एम प्लेइंग द वीडियो, प्लीज चेक द वीडियो।
This little toy is called a drinking bird. You put a cup of water in front of it and its head dunks into the cup. Eventually the head bobs up again, but then it goes right back into the water. If you don't know much about thermodynamics, the drinking bird might seem like it could go on forever without an external source of energy powering it. A perpetual motion machine, in other words. But the toy isn't a perpetual motion machine because perpetual motion is impossible according to the laws of physics. One of the reasons is the first law of thermodynamics. One of the main goals of thermodynamics is to describe the transfer of energy. We've already described two processes as a transfer of energy, work and heat, and they're both connected to each other. As a thermodynamic system does work, it loses heat. When work is done on a system, it gains heat. So heat is converted to work and work is converted to heat. Together, the work and heat transferred into or out of the system represent the change in its internal energy, which, as you might recall, is the total kinetic energy and potential energy of all the molecules in the system. This idea that the change in internal energy is equal to the change in work plus heat is so fundamental that it's known as the first law of thermodynamics. So we can have an equation to use for analysing problems. We write the first law like this. The internal energy, U, of a closed system is equal to Q, the heat transferred to the system, minus W, the work done on or by the system. It's important to remember that when we talk about changes in internal energy, if heat is transferred into the system, Q is positive, and if heat is transferred out of the system, Q is negative. And if work is done on the system, W is negative, and if work is done by the system, W is positive. Some textbooks will change those signs around, so it's worth keeping track of what the positives and negatives mean. Now you'll notice that the first law of thermodynamics describes only those two factors, work and heat, as affecting a change in internal energy. That's because as long as the system is closed, meaning it's isolated from the rest of the universe, there just aren't any other factors involved. The amount of heat lost by the system is exactly equal to the amount of work done by the system, and vice versa. So really, the first law of thermodynamics is just another way to describe the conservation of energy, which keeps coming up in our lessons because it's such a key principle of physics. There's always some kind of heat loss, like through friction. Even that tiny amount means that the motion can't continue forever. It will eventually run out of the energy it needs to drive the work it's doing. That's part of why the drinking bird isn't a perpetual motion machine. It relies on the energy it gets from the cup of water to power its movement. The bird is filled with a fluid that has a low boiling point, so it can easily change from a gas to a liquid and back, with just a slight change in temperature. There's some liquid at the bottom and some vapor at the top. When the bird's head dips into the cup, it gets wet. It keeps bobbing back and forth for a while, and as the water evaporates, it cools the vapor in the bird's head, which condenses into liquid, creating a partial vacuum in the head. That makes liquid travel up the tube. The head gets heavier and dips back into the water. But the tipping makes a bubble rise through the liquid into the bird's head, sending more liquid into the bottom and setting the little bird swinging and starting the cycle all over again. But it still needs the water for it to do its thing. Once the water in the cup runs out, the bird stops moving. Now, there are four basic types of processes where the thermodynamic properties of a system, generally generally an ideal gas in some kind of container, can change according to the first law. In each case, one property is held constant, volume, pressure, temperature, or heat, while the other properties change. Variations on all these properties are used in all kinds of machines, especially engines. First, there are isovolumetric processes where the volume is held constant, usually because the gas is in a rigid container, while heat is added or removed. As you add heat, the pressure of the gas will increase and so will its temperature. As you remove heat, the pressure and temperature would decrease. Isovolumetric processes are kind of boring as thermodynamic processes go. The gas is stuck inside its container, and no matter how much heat you add, the gas doesn't do any work. You're just increasing its internal energy. But isobaric processes, where the pressure is held constant while heat is added or removed, are a little more interesting. Here, the volume of the container is allowed to change, usually because the gas can move a piston. As you add heat, the volume and temperature of the system increase, and as you remove heat, the volume and temperature decrease, which means that an isobaric process can do work. Here's why. In earlier episodes, we've said that work is equal to force times distance. In this case, the distance the piston moves. We've also said that pressure is equal to force divided by area, which means that force is equal to pressure times area. Here is the pressure of the gas times the area of the piston. So work is equal to the gas's pressure times the piston's area times the distance it moves. And one more step. The area of the piston times the distance it moves will be equal to the change in the volume of the container. So the work done during an isobaric process is equal to the pressure of the gas times the change in the volume. If heat is added, the volume goes up and the piston moves outward, so the system does work. If you push the piston inward, you're doing work on the system, so its volume goes down. The third type of thermodynamic processes are isothermal. That's where temperature is held constant, usually by connecting the system to a much bigger system whose temperature would take a lot of heat to change, known as a heat reservoir. The heat or volume of a system is then changed very slowly so that the other properties can adjust while the temperature essentially stays constant. An isothermal process is kind of like an isobaric process in that if you add heat, the volume will expand, so the system will do work. But for isothermal processes, you can't use that simple W equals P delta V equation because the pressure does change. Instead, you need to take the integral of the pressure with respect to volume. This way, you're still calculating work, but you're taking the changes in pressure into account too. Another difference between isobaric and isothermal processes is that since temperature is held constant in isothermal processes, the internal energy of the ideal gas can't change. And the first law of thermodynamics says that heat minus work is equal to the change in the internal energy of the system, in this case, 0. So the work done by the system will be equal to the amount of heat added and vice versa. Finally, there are adiabatic processes where no heat is allowed to flow in or out of the system, but the gas can expand or be compressed. Again, the equation for the first law of thermodynamics helps us out here. Q is 0 because the heat of the system isn't changing, but the internal energy of the gas can change, so the system can do work or have work done on it. In fact, the change in the internal energy of the gas will be exactly equal to the negative of the work. But this is all just the first law of thermodynamics. There's also the second law, which says that heat will spontaneously flow from something hotter to something colder, but it won't flow from something colder to something hotter. And that's because of this thing called entropy. Entropy is often described as the inherent disorder of a system. The more disordered the system, the higher its entropy. So a gas, for example, with all its molecules randomly bouncing around, has a higher entropy than a solid with its molecules neatly arranged. And a more general way to state the second law of thermodynamics is that in real life, entropy can only increase overall. That doesn't mean that entropy can never decrease in certain situations, like gases do sometimes turn into liquids or solids, obviously. You've seen water vapor condense and liquid water freeze. But if the entropy in a system decreases, that means the entropy of the environment around the system must increase enough to compensate and then some, so that there's an overall increase in the entropy of the universe. Say you put water in your freezer to make ice, for example. The entropy of the water goes down as it freezes. But meanwhile, your freezer is putting out heat as it works to keep itself cold inside. And the heat from your freezer is increasing the entropy of your kitchen more than the entropy of the ice is decreasing. So overall, there's an increase in the entropy of the universe. Remember that. Every time you're making ice, you're increasing the disorder of the universe. Now, entropy's tendency to increase has to do with probability. To see what I mean, picture a shattered ceramic mug. There are molecules that make up that mug, and there are lots and lots of ways that those molecules can be arranged in space, and all of them are equally likely. But only in a few of those arrangements can the molecules make up a whole, solid, unshattered cup, the state where they have a lower entropy. Still, there are lots of possible arrangements of those molecules where they could make up a shattered cup, a set of pieces with a higher entropy. The cup can be shattered into pieces, 300 pieces, with the pieces far apart or very close together. And every way the cup can shatter is another
Good grammar and spelling are important. But if you want to write